Hello, I'm Tom. I work at Grafbase. Yeah, I guess other people joined between the two talks. I just gave a talk before, so I'm going to reintroduce myself and what we are doing. So I'm Tom. I work at Grafbase. We are a GraphQL Federation solution that's based on the same standards as everybody else who's doing GraphQL Federation products. We are high performance. We are very, very customizable. That's the whole topic of extensions that we touched on right now and that we are going to touch on in this talk. And we are also entirely 100% self-hostable, air-gapped. Yeah, so that's the differentiating things. Federated GraphQL, you have many GraphQL APIs called subgraphs. You take their schemas, you merge them in a process called composition. You get a composed schema, you pass that to a Federation Gateway, and the Federation Gateway is going to serve that composed API and orchestrate the requests to the subgraphs. That's what you need to know for this talk. Great, so I'm going to talk about authorization. Why would you want to do authorization in a Federation Gateway? It's not your own code, it's a third-party component. Why? So first thing is, it's the first point of contact with the outside world. So that's a good place to do authorization early. It has a view of the whole merged federated schema. So it knows what belongs in which subgraphs, and it has the whole view. It has the whole request context. It has the whole request from the client or from a previous gateway, and it can see everything. Subgraphs, like they often get more selective sets of headers and all that. It's a single point of enforcement. So all the requests have to go through the gateway. So instead of authorizing for every subgraph inside the subgraph, why not put it in the place where you can enforce it in one place? And the last one is entity resolvers make subgraphs lose context. And what does it mean? What it means is that the subgraphs, since they are resolving only part of the request, part of the GraphQL query, they only see part of the query, and they don't have a lot of context to go on to make authorization decisions. So here we have on the left a traditional GraphQL resolver where I want to authorize like the photos fields on the friends, on the users. So friends are users. It's a kind of social network situation. Well, I know it's like if I look at the path of the request, I know it's the current user's friends. So I can make an authorization decision and guess, okay, I'm going to allow the current user to see their friends' photos. On the right, it's like, okay, maybe it's the current user's friends, but you're the user service, you're resolving users, and they're asking for a user with ID 1, and you don't know who's asking and why. And that, in that federated context, like it's not a great way to do authorization. You can't make a good decision. So there's this directives for authorization in the Federation v2 standard, and we're going to start with these. They're all based, well, not all, but they're the basic thing that they work with are claims or scopes, and they are derived from your JWT claims if you have them. Or you can insert them based on request context with a plug like scripts, coprocessors, anything that lives in your gateway that's your own code. So you can add extra claims based on the request. First one is authenticated, and basically if any claims is defined, so you put it on a field or on a type, and that type or that field is going to be visible and usable by the request that has these claims, that has any claims at all. So that's typically for discriminating parts of your schemas that are for logged in users and or logged out. Require scope is the same thing, except instead of any claims, you're going to give sets of claims, and then there's two arrays, and it's like sets, alternative sets. We're going to see that it's much clearer with the example than I could explain it. And policy is exactly the same thing, except instead of claims, you pass policies, and policies are basically scripts or coprocessor functions in your custom code on the gateway. So that could call to an internal service or anything like that. And if we look at an example of policies, here we have an admin dashboard query that would be a typical usage. And we are going to allow access to the admin dashboard to requests where the IPs are listed, so that's an internal client, or it's a support agent and we are in business hours. So that would be an example usage of policies. That's sufficient for very basic role space access control and limited attribute space access control. What I mean by that is that you can assign roles based on, well, typically JWT claims, so based on the authorization header in the request. And then you can allow access to parts of the schema or parts of the types based on that. So you could see only these people see this group of people, this role sees the admin dashboard, or this group of people sees that type. But what you can't do is have decisions that are tied to data. So you can't make a decision, okay, based on the input arguments or based on output data returned by the subgraphs. We're going to dive into that. So you can't express relationships. Examples of relationships would be users can see the photos on the profiles of their friends. Yeah, either they can see profile photos or not. I can see the balance on my own bank account. Like you need the data on which bank account ID and which user does that to make an authorization decision. I can see the medical records of my own patients, healthcare thing, and my direct manager can approve my expense requests if they are less than 5,000 euros. Great. So how do we achieve that? And just to recap, we need to look at input data, so arguments passed to resolvers, and we need to look at response data as well, because sometimes you don't have what you need to authorize. Authorization in a very broad sense could be like a last-ditch access control to avoid leaking things that would be catastrophic to leak, for example. So authorization must be taken into account by the query planner, and we are going to dive into that. So we have an example query here where we have a blog API and we have a user ID. We are going to query that user's posts, and then for each post, the comments and the contents of the comments. We are going to validate control access at the post level and at the comment level. And basically for 1 and 2, you can get posts and you get the user ID in the request. So with a policy, you could conceivably look at the query, look at the variables, and guess, okay, the user ID is allowed to see these posts. But what if you need data that's on the post, that's arrow 3, or you need anything on the comments because you don't know anything on the comments that are going to be returned from that request? Like you can't authorize that. So our solution is extensions. I've talked about extensions in the previous talk. It's a different kind of extensions called authorization extensions. And they are WebAssembly plugins that you pass to the gateway. There are open source ones. You can build your own. They are sandboxing. They are pretty fast. You can do arbitrary I/O. It's important for authorization. Like if you have an enterprise kind of situation with like a SpiceDB or Open Policy Agent or a service like that that makes helps you make these authorization decisions, it's important that you can do these these I/O. And they can define their own directives that are going to be used in query planning. Let's look at that. Okay, I'm running out of time. So we want to do input validation. And for that, we import a special scalar called input field set. We define our directive. So that's in the extension, it has its own definitions. And we take all the arguments by default. Then we apply that directive we just defined. So we call it authorized. We apply it to bank account user by user email, takes an email, and it's an authorized field. And what we get is, so we define, sorry, that's Rust code. I hope that's okay. We define the authorized directive, the shape. It has an argument here. It has an email for that field specifically. So you define that. That could be more generic, but here we are validating very simply. We authorize the query. We have the headers. Token is like anything that's produced by the authentication code. And query elements, which would be this input data. And then like you can deny by default or allow by default and then do things. Here we do a very, very simple comparing to hard-coded value, but you could have arbitrary logic in there. And you notice it's a for loop. We do a batch of authorization decisions. It's all batched. It's never called resolver by resolver, but you get a batch of as many authorization decisions as possible to resolve, and you can resolve that in bash. Great. The other side of the coin is when you authorize on output data. So you don't have the data you need in the input arguments. So you would need, by the way, that's input arguments. Sorry, I want to go back there. Input arguments from queries that are sent by the user, but also on queries that are sent by the gateway. So the gateway is going to fetch the comments, and there's going to be comment LEDs in there. So you really want to be between the gateway and the subgraphs, and not between the user and the gateway. Great. Yeah, output data. Obviously, for output data, you need to do that after the request comes back from the subgraph, and it's going to cause that field to become null. Yeah. So let's see how we would do that with policy. We say check access to user social security number here for the social security number. And let's imagine you need the ID and the user type to make a decision on, okay, can I see the user's social security number? Yeah, let's try this. Problem is you get that query. They want only the social security number. How do you decide that if you don't get the data that's returned by the subgraph? So what you do is define a field set, an extension that takes a field set, and field set is taken into account in query planning, which means you apply this, and that works like an @requires directive, where it's going to basically transparently for the user only sees that query and is going to get the social security number or not. That doesn't change anything. But internally, like the gateway knows that the authorization extension needs these fields to make a request. So it's going to return them from subgraph, pass them to the authentication extension, the authorization extension, sorry. So you can request additional data and have all the context you need to make that decision. Takeaways is that you need to have dependency on data, and you need to be in the query planner in order to make these authorization decisions for relationships, for complicated fine-grained permissions. Yeah, and that's what enables you to implement fine-grained attributes-based access control or relation-based access control with a Federation Gateway. Thank you very much.